Welcome to Onshape for Makers, where we are creating models to take to the shop. Tonight we are doing Sheet Metal 101 with a fairly simple sheet metal part. We're going to add a little face move and face pattern into it to make it fun. It is from the Too Tall Toby website and the Too Tall Toby YouTube channel. This one was in a contest in, I believe it was March of 2023. I don't know if it's still around, but we have a drawing of it I'll share in just a minute. What to expect? We're going to do a sheet metal start. We're going to do a couple of flanges. We're going to do a bend relief to fix a notch. We're going to have to do a face move and a hole tool hole. And then we'll talk about patterning those 6 slots down the side. The slots are right here on the side, and we will do them as a pattern in a sketch. We'll do them as a pattern of features down the side, and then we'll do them as a pattern of faces down the side. When we get through, we will talk about how to check your model for accuracy and how to check your model for performance. If you're having problems with your system hanging up or acting slow, there's some things you can look at to get a hint as to why it's not happy. This is the print. It's from Too Tall Toby. You'll notice it says 2,700 kilograms, and it has a 512 kilogram. That's not where I wanted it. 512 kilogram mass property for the box. If we get the right numbers, we should come up with that at the end. That's kind of like a checksum. This is your part. There's not a lot to it. Its only weird thing is there is 1/10 of 1 millimeter between these two to resolve zero thickness problems. Otherwise, it's pretty straightforward. We're going to draw an outline. We're going to do a thin extrude. We're going to fold up a flange, and then we will fold a partial flange inside the back tab at 1/10 of 1 millimeter offset. We will fix the gap or the tear, bend radius tear here. We will put the slots down the side. We will put them down as a sketch pattern. We will do it as a feature pattern, and we will do it as a face pattern with a select group option. That's interesting. When we get to that point, we will mirror the part to make a full part, put the radiuses on here and here, put the hole in with the hole tool, and we will be finished. I would suggest you want to take a copy of this on a screen grab and hold on to it so you can refer to it as we go through this. This is how we will do the properties. I'll come back and show this to you. To get the property for mass properties, Toby uses something that I think are the mass properties for SolidWorks, which are slightly different than the mass property defaults for Onshape. So we will use a custom value over here to get his numbers into the Onshape system so our mass property of 512 comes out correct. We'll also talk about tab performances and how you can figure out between this one and that one why your model is taking not very long or way too long, and it shows each feature and how long each feature takes. We'll go through that. We'll also take a really quick look at the evaluation tab for your system, your browser, and your network connection. Most people don't even know this is in here. It's an interesting thing, and it's one of the things the help desk is always interested in if you have a problem. So we're going to start with this drawing. We're going to build a model, and we're going to have fun doing it. Okay, starting a new part studio. We're going to go to the hamburger menu in the upper left corner, pull it down, go to work units. We want length as in millimeters in 0.1 display decimals. Under mechanical, you'll want gram and set to 0 decimals. a green check mark, and we're ready to start. Now, if you remember, we're going to do the outside of this and down this, so it's 66 tall, and outside to outside, except for the lip, is 127. The lip is an extra 24. So we will start on the front plane, go to Sketch, go to N for normal, and we will start with a line somewhere out here, come down that far, and that number is 66. We're going to come over to the origin, and that line is 127. And then this is 66 minus 6. And this is 24. And the question is, where in the world did the minus 6 come from? The minus 6 came from the default wall thickness. The material is 6 millimeters thick, and the bend radius is 6 millimeters. We're going to use that in the next step, but that's where the minus 6 came from, and that allows the material, come on, just don't do this. That allows the material to drape up over the top, and the top of the material is still the same height as this. Okay, so we have the sketch. We're ready to go into sheet metal mode. To go into sheet metal mode, we will accept the sketch. I'm going to type in P for planes to get rid of them. I don't want to look at them. And I'm going up here next to frames. You've got your add-in tools. Next to add-in tools, you've got sheet metal tools, and you want sheet metal model. Under sheet metal model, we'll come down here. The thickness of the material is 6 millimeters. The bend radius is 6 millimeters. We want to go to extrude, and we're just going to box select all of that. And if you'll notice that when I box selected it, I managed to get the material going on the inside. If yours is going the other way, simply go down to thickness and click the arrow and it will go the other way. But you want the material to be inside this and outside of this little lip, and that will create our part. The width of the box floor from this tab to here is 80, but we're only going to build half a part. So what we want for a depth would be 80 divided by 2, and we hit the enter key, and there is the start. We're going to right click, at least I am, change appearance and go this way because my monitor does better with the reds than it does with the blues, and it's easier for you to see. So we have a part that is 40 wide, and we think it's the right height. We'll go down to the right hand corner where it says show measure details. We'll click it. We'll click on that face. Click on the bottom face, and it should say 66. If you get that, you've got the right answer. We will be using that a lot tonight as a sanity check. Okay, now that we have done that, what we want to do is we want to turn this outside flange up. This outside flange is also 66, so we will, well, let's see, I pulled the wrong one. Let me put the right one back. We will come up here to our sheet metal tools, and we will take flange tool. You can click anywhere on this and it will give you a flange. If the flange goes the wrong way, select bend angle arrow and it will go the other way. Now what we want, we have enter, we have outer, we have middle, and we have hold line. what we want to do is we want to hold the line, because the bend line is the width of this part that we made, and we don't want the sheet metal tool to shorten that up, so we will go with hold the line, and we will make this part up to 66 and enter and check mark. And if you're in doubt, when you look at the blueprint, you will notice that outside to outside is 104, which would be 52 for a half part. So we can go back to the tape measure, we can check that face, we can check this face, and it should be 52. That's how you can tell if you should have used inside or outside or mid or hold the line. If you're in doubt, just check it. So we have two parts. What we need now is the part that curves behind this. But right now, the way it's drawn, if I put a flange here, it's going to collide. I'll just show you. It will collide with that surface and create a problem. See the bright little red mark? And it's a 0 thickness problem. So I have to come up with a solution to get a 1/10 of a millimeter. The way to do that easily is to take move face, which is one of the primitives, or base parts, whatever. Maybe primitive is the wrong word, I don't know. Anyway, and we're going to simply back it up 0.1. I put 0.2, that was the wrong answer. 0.1 tab. And that will move this whole face back 1/10 of a millimeter. And I'm going to say green check mark and go back to the flange tool and select it again and wrap it back around. And you'll notice this time I don't get an arrow. I have a ever so slight gap right there, so it lets it work. Now this distance from here to here is not 25. That distance is 30, I believe it is. It's 30 right here across. So we'll come back and make it 30. And that gets everything except it gave me a full flange. When you green check mark, I have a full flange, and I don't want a full flange. What I want is a partial flange. If you see this here, then I have only a 35 millimeter flange from the top down, and then I have a relief and then just a straight wall. So the way to do that is to come back, reopen flange 2, and select partial flange. And pull this up, and this should be, I'm going to put in 35, even though that's not going to work. That will get us close. And I'm going to select green arrow, and that 35 is probably closer to 29 or 30, so let me check it. I'm going to check that surface and that surface, and that is 31, and it should be 35, so I'm 4 short. So let me pull up this, and we are at 35, and I want to be at 31. And that will get my 4 that I was missing. And when I go back and check it again, off of that surface, check it, come on, check it. Having a little trouble here. Okay, go back, check that surface against that surface. I'm at 35. So I now have my full size flange. I have 2 problems left. One, I shortened this up by 1/10 of a millimeter to get this to move back, but now I need to move this back 1/10 of a millimeter, or the mass properties will be wrong when I check the model. And I need to replace this with a square cut that is slightly smaller. The way to do both of those is we're going to go back to face move. We're going to select that. I'm going to go 0.1 out and check mark, and that puts the 0.1 back in all of this. And then I've got to correct this. You can't just delete it because we are in sheet metal mode. And over in the features list, you'll see sheet metal mode over here. When you start that, sheet metal mode puts what you can think of as a wrapper over the top of your normal sketch tools. And they tend to work just a little different as long as you're in sheet metal mode. And one of the things you can't do is you can't select this and delete it, or you can't draw a box around it and cut it. You're got it. So you've got to use a sheet metal tool to deal with it. We'll come over here to Bend Relief Sheet Metal tool, and we will select this bend relief. And we have lots and lots of options, but the one we want is tear. And tear in sheet metal language means don't leave a relief, just let it rip. So we're going to click the green arrow, and the relief went away, and we're back to square one. Let's click on this surface, start a sketch, go in for normal, and then we will do a corner rectangle, and we will start here and we will go over and down. The width of the slot is 4 millimeters, and the length of the slot is 10 millimeters. That is up here in this part of the drawing. Once we have that, we can say green check mark, extrude, remove, select that, green check mark, and we're through, and that solved that problem. The only thing we have left are the slots and the hole and a couple of fillets. To draw the slots, I have 5 slots down this face. I can go to this face, I can start a sketch, go in for normal, go L for line tool, Q for construction, and simply draw a vertical line, and the length of the vertical line is 40. Let me pull this over here. We are here. The length of these lines is 40. This is a strange way to draw center to center. The width of the slots is 5 radius, or 10 on the width of the slot. And the slot starts 8 millimeters from the top flange to the center of the slot is 8 millimeters. So when we come over here, what we will do is we will come over here and we'll do an escape, and we'll pull this down, and I'm going to do a D for dimension and simply go 8. And the first slot starts from the back side, and it is 37 millimeters to there, and that is your first slot. Now, to make a bunch of slots, you can draw a bunch of lines, or we can go up here to linear pattern, and we can select this and tell it we want to go to the left. The distance between the slots is 15 millimeters, and the number of slots we want is 5. And it will give us 5 lines. Then we can go to the hole tool, which is under the offset tool is a slot tool. And we can simply poke all 5 lines. And then we can look up here and it asks for the width of it, and the width should be 10. And those will give you your 5 slots. We do a green check mark. We'll come to extrude, remove, and it's going to ask what, and we want to remove everything in sketch 3. So some of you may not know, but you can select the sketch as what to do in extrude or several other tools. But we do green check mark, and there are all the slots in that part. That's one of the ways you could do it. Another option would be, and let me go back to extrude 2 and take all but one of them out and just do one extrude, and then I can go up here to linear pattern, and under linear pattern I have feature pattern, and it wants to know what feature. So under the feature list over here I can select extrude 2 as the feature I want to pattern. For direction I'll select a horizontal line somewhere. For the distance, I'll type in 15, and the instant count is always the one you start with plus how many you want. You want 5, so you have to put in 5 even though you're only creating 4 in the pattern, because, yeah. So when you do that, that will give you the same thing, no difference. The creation time is marginal here. It can be a good deal longer sometimes. Those are 2 ways to do it. Okay, option 3 is to pattern the faces, which would be these faces. So I'm going to right click and do suppress, and suppress is the same as comment that line out so it doesn't execute when it builds a model. I'm going up here to linear pattern. I'm going to go down to face pattern, and there's a little thing that says create selection, and I'm going to select on it, and under it or options I'm going to take tangent connected, and I'm going to select this one face and it will pick all 4. I'll say add that to the selection. So now we have all 4 faces in the pattern. And I'm going to say direction is this way. The distance is 15. The instance count is 5. And check mark, and you get what appears to be the same. In this case, it doesn't matter. If you have something that has a whole lot of faces that you're patterning across a large piece of sheet metal, this actually runs much faster than any of the other options I showed you. In this little part, honestly, it makes no difference, but we saw it and we survived it, so we're moving on. When I come up, I'll select fillet. If I want to pick this, I can very carefully pick it, or I can simply make a box. If I make a box going left to right, I only take what's contained inside the box totally. If I had done that differently, if I had gone the other way and picked this, I would have picked not only the vertical part, but all of the other lines that had crossed it, and I would get all kinds of things I didn't want. So when you pick and you want a single item like trying to do fillets, a quick way is just do that. The quick way is to draw a line, go left, and you catch just the corner. By the way, that's a really nice way if you're trying to do tangent constraints on circles and lines to make a left to right box. It works really quick. But there's our part. We have a complete half part, hopefully. We're going to mirror. We're going to select the entire part. For the mirror plane, we're going to select the mating surface, and we're going to select add, so we only get one part when we're through. And that gives us everything but that hole. We'll click on there, in for normal, zoom a little bit, and that gives me a good view of where I want to be. I need a 10 millimeter hole, and the 10 millimeter hole for that is 142 from the back face to the center of the hole on the center line. So figuring the best way to do that, I'm going to take the hole tool and I'm going to zoom in, and with a mate connector, and I'm going to put the mate connector right there, which is the center of the back wall. And I'm going to left click on mate connector, and it will bring up this little option, and it's a delta move to move the mate connector. I want to move the red mate connector, which is X, and I want to move it minus 142. And what that does is it puts it exactly where I want it. And I simply hit check mark. The other way you could have done it is you could have gone in and started a sketch here and draw a construction line from the center down to there and done 142 and use that the same way to create your hole. It was just one step shorter. Doesn't make any difference. Now the question is, do we have the right size part? To find out, we're going to right click part 1, we're going to assign material, and we're going to pull this up, and this is 2700, and 2700, if we go to custom and we give it a name, call it mine or yours, and I'm going to type in 2.7 E, lowercase e, minus 3. Scientific notation, right out of chemistry and physics. Enter key, green check mark, and that sets up the mass properties to match what's in the drawing. You go to the scales in the bottom right hand corner, you select your part, and it should say 512. If it says 512, you have a good part. Now I promised to show you a bunch of other stuff. Over on the very left-hand side, there's a clock that says performance. If you click it, you get all kinds of information. I'm going to hide document performance, and I'm just going to go to features. This is a feature list of every feature that you incorporated into that model and how many of them there are. A sketch is a feature just like an extrude is a feature or a hole is a feature. And a feature is, in software terms, a subroutine call. That's really how the silly thing works. Total regeneration time, if you click this little clock that says show regen times, it will show you each feature and how long it took to execute that subroutine call. Sketch 1 was 5, 8, 18. Fillet was 125 milliseconds. Move face was 153 milliseconds. Mirror, which we mirrored the whole entire part and then combined it into one, was 263. If you look, the total time is 1.68. Disclaimer here, I am running from the middle of nowhere, Texas on a Wi-Fi internet connection, not fiber, not copper, but Wi-Fi. I have a DMZ in the house. I have a VPN running out of Chicago to connect all of this together, so I have a reasonable amount of latency in my network. Yours probably is a good deal faster. However, with all of that said, Onshape performs very well. If you come over in the far left corner and look at the bottom, it'll say network and region, and it will show you where you are, what your latency time is. If you look at WebGL and extensions, it will show you if your browser has everything loaded that it's needing to use to operate well. Here's your browser. Here's everything you really wanted to know, including what the rendering engine is on your graphics card. If you ever call in a help ticket, that's one of the things they're going to ask you to post. But this stuff is available, and there's a ton of stuff available. The other thing, if you click down at the very bottom where it says Studio and right-click and move up to where it says Show Code, I'll bet you never saw that. If you say Show Code, there is the entire script that is your part. That's what Onshape stores when it stores your part. It doesn't store a part. It stores the build instructions. Every time you open it, it rebuilds it. This is everything it takes to make your part right here. If you wanted to write it, you can write your own feature scripts and add into that. I haven't yet, but someday. Anyway, hope you guys have fun. If there's something I wasn't real clear about, leave it in a comment and I'll come back on the next video and see if I can cover the rest of it. Catch y'all later. Have fun in the shop tonight.